Welcome to This Explainer. Today, we're unpacking a massive shift in how software actually gets built. So, if you've been paying attention lately, you already know that modern agentic AI has completely flipped our daily engineering routines upside down. We are officially living in the age of vibe coding. This is where AI tools can churn out just massive amounts of code based on a simple, high-level intent. But as we're going to see, that incredible speed, it comes with a really dangerous hidden cost. We're going to look into why generating 1,000 lines of code almost guarantees you 1,000 lines of bugs. Right, so what actually happens when an AI writes 1,000 lines of code before lunch? I mean, on the surface, it feels absolutely amazing. It feels like you've just hired this legion of tireless interns who never sleep and never complain. But the reality is actually quite different. The sheer velocity of vibe coding brings a massive new bottleneck downstream. You see, the code generation itself isn't the bottleneck anymore. It's the humans who have to integrate, review, and somehow untangle those 1,000 lines. It's a complete illusion of speed.
Think about this for a second. When an AI hallucinates today, it's not just making a cute little syntax error. Oh no, it creates 1,000 lines of completely vibe consistent, but functionally broken logic. It looks right, it feels right, but underneath, it's fundamentally broken. And this right here is exactly why 1,000 lines cause bugs. Speed is a total illusion if all it does is create a bigger pile of broken logic for human reviewers to sort through later.
So, to solve this massive industry problem, we need a production-grade safety framework. Here's our agenda for today. 1. The illusion of speed. 2. Spec-driven development. 3. Formatting AI instructions. 4. Curing approval fatigue. And 5. Zero-trust AI safety. Let's get into it. Section 2. Spec-driven development. There is a stark contrast happening right now in our industry. Traditionally, we were code-first typists. A vague idea basically meant opening up an editor and just typing until something worked. We were emotionally attached to our code. But in this new age of agentic AI, we have to transition to being technical architects. In this world, the code itself is entirely disposable. You aren't spending 12 hours debugging a stray semicolon anymore. If your specification is rock solid, you can literally throw the whole codebase away and just have the AI regenerate it in an afternoon. To actually make this work, your specification has to become your architectural North Star. To stop the AI from just wildly guessing, we use behavior-driven development. This forces the AI to think in really strict terms of state, action, and outcome. Using formats like the Gherkin syntax, given, when, then, when you break down your design into precise pieces, edge cases, and visual aids, you completely eliminate the guesswork of vibe coding. You're giving the AI a concrete blueprint, not just a vibe.
Moving on to Section 3, Formatting AI Instructions. Now, check this out, because this is wild. A recent study revealed that LLM agents experience up to a 40% performance drop when they're just parsing generic, unoptimized Markdown files. 40%. That is a massive drop in accuracy simply because of how your text is formatted. Every single character, new line, and indentation you send translates directly into your development budget and system latency.
So, to get maximum accuracy and bypass this reasoning format tax, you really need a hybrid approach. You want to use clean Markdown headers to anchor the AI's attention for your narrative instructions, but the data shows that when you have deeply nested configurations, you actually must switch to flat YAML blocks. YAML hits nearly 52% parsing accuracy for deep nesting, which completely crushes JSON and XML. By optimizing your format, you're keeping your AI operating on strict, cost-efficient rails. Honestly, optimizing this format is step 1 to ensuring your AI doesn't misinterpret a prompt and just dump 1,000 lines of broken logic into your codebase. And when things do break, because let's be real, they absolutely will, you have to change how you talk to the agent. You've got to shift away from vague symptom prompting, like, hey, the button doesn't work. Instead, use forensic evidence prompting. Give the agent the exact terminal logs showing a 403 error. Always provide a failing unit test or a curl command first so the agent fixes the actual root cause rather than hallucinating and rewriting unrelated code that's just going to cause more bugs. Section 4. Curing approval fatigue. Here's an alarming reality for us to face. Frequent AI users are actually 45% more likely to experience high burnout. Why is that? Well, developers are drowning in AI-generated pull requests. They're suffering from what we call approval fatigue. When you're constantly bombarded with these micro-approvals, you just start reflexively clicking approve without really checking the machine's work, just trying to keep up with the flood. And that is exactly how those 1,000 lines of bugs slip silently straight into production.
To scale this safely without burning out your entire team, you must deploy continuous AI code reviewers. And you basically have 3 tiers to choose from here. Tier 1 is managed and generic, great for quick starts, but it totally misses team-specific roles. Tier 2 is a hybrid setup where you're running custom scripts triggered by your continuous integration. And then Tier 3 is a fully custom graph-native runtime for those massive legacy code bases where you absolutely positively cannot afford a mistake.
Let's look at how Tier 3 actually works at full scale. For a massive code base, standard retrieval methods just strip out all the context and structure. Instead, Tier 3 uses knowledge graphs and sub-agent pipelines. So it has specific, dedicated agents for searching, mapping impact, breaking down tasks, and finally coding. This means the AI can tell you exactly what breaks when a change is made, mapping the impact precisely, rather than just confidently guessing and creating one of those 1,000-line disasters.
Section 5. Zero Trust AI Safety.
Because, if we don't build guardrails, things like this happen. This is a real incident from the source material. A totally simple prompt to create a button triggered an agent that was operating in YOLO mode, which, yes, literally means auto-approve. Lacking specific data, the agent suffered from context hallucination. It just filled in the blanks with whatever strings it could scrape from its context window, connected to a deprecated legacy system, and blasted out 50 false internal emails. It was optimizing for its goal, for sure, but without safety checks, it went completely rogue.
To prevent that kind of rogue agent scenario, you have to implement a hybrid policy server. Think of it in 3 steps. Step 1 is a structural check, kind of like traffic lights, that deterministically blocks bad tool usage based on roles. Step 2 is a semantic check. This is an intelligent referee, where a secondary LLM verifies the actual intent of the action so it doesn't violate privacy policies. Only if both of those pass do we move to step 3, which is execution.
And this all builds into our essential guardrails. By executing tasks in disposable Docker sandboxes, any malicious code hits a hard permission error immediately. We use human-in-the-loop gates for any high-stakes actions. We enforce context hygiene by using regex placeholders to mask sensitive data before the AI ever even sees it. And finally, we require AI-generated test coverage, so the machine is forced to write the tests to validate its own output. This is how you ensure the agent's vibe doesn't accidentally deploy 1,000 lines of bugs into your core architecture. So, as you master the spec-driven Zero Trust framework, and you successfully stop 1,000 lines of code from becoming 1,000 bugs, it leaves us with this final, really provocative thought. If you're acting as an architect, deploying custom AI reviewers, policy servers, and complex sub-agent pipelines, if you can reliably work with a squad of highly constrained, hyper-efficient AI agents, do you even need to work as a human team at all? Definitely something to think about as you build for the future.